This is Codescence. I'll be taking you through the Brownfields project, more in detail on our source files and our architecture, as well as the testing framework. My colleagues have already touched on some of the aspects. I will just dive into a more detail of the source files and the testing and also the architecture that we followed for this project. So without taking much of time, I will dive into the presentation. Just give me a moment. So I'm, as I've mentioned, I'm Codescence, so I'm presenting an overview of our Brownfields project. So the overview is, we have a project overview on the first slide, software development source files, of which that's where I will touch mostly, as my colleagues will touch on the other parts of the slide. I'll move to the next slide on the project overview. So we had the client-server architecture in our first iteration of the project, where we only had a client-server and the protocol. There was no database. Information was saved on runtime using variables. So meaning when the project was reset, new server configurations and new client connections were supposed to be redone, which this is improved during the upcoming iterations, where the database is now included and we have a web API layer, so to separate the functionalities of the server from the other parts of the code, which is called layered architecture. So the overview now is, the real goal was to refactor an existing code base of the robot world. So the requirements of the server were the server manages the robots, it processes commands from clients, and handles the interaction with a configurable grid. So we have the client requirements. So the client comes in as a text-based or command line interface, and at a later stage, the client is improved. The client is improved to use a graphical user interface. Then we have the protocol, and then we have the protocol. Sorry about that. We have the protocol, which now was the standard communication between the client and the server. So a protocol is an agreed way of communication between the server and the client. So the protocol is a go between the server and the client. So the software source files, we use GitLab for version control and for easy production with my group members. So we're using the user stories, the backlog approach, and then also this helps us learn and improve more skills of committing and merging, avoiding conflicts. So I'll just share our GitLab structure. So I'll share the GitLab tab. So here we have 269 commits from the group members. We have the source here where we have the code. The code is well composed. The code adherence were followed: encapsulation, polymorphism, uses of interface, and inheritance is used, and there is composition. As you can see, each functionality is probably its own package We have the database package. Remember, this code is a final product of our code. So we have the database, we have the responses, we have the client, we have the ORM, we have the reference server, we have the server, and the web API. So the reference server, we're using it for acceptance testing. So if the tests pass against the reference server, it means your tests are correct. If then the tests fail against the server, it means you need to adjust the server because the test already have worked with the reference server that was provided uh, by our performance team. Maybe just to go into one of the files here, we have the server package, where also there is further composition into commands, configuration, the JSON, the world, we have the handler. So the standard of the code structure, I believe, were strongly followed in this project. We also have in the project, we have the Makefile, which is for managing the compiling, the building, and running tests of our uh, program. We have the POM file, which holds the dependencies for our project. Here we have the JSON dependency, we have the JSON core, we have the API unit REST. For the web API, we have database Javelin for the server, JUnit for unit testing, and Mockito for where we needed to do some mock during our acceptance and unit testing. We have the Git.yml file there, which runs our Docker pipeline, and the stages were clean, build, test, package, login, build, and deploy. So the stages would run in that specified order for our pipeline. And going back to the files, we had the unit testing. Let's just go to the test there. So we had acceptance tests that we wrote, and the unit testing acceptance test for the database to check if the code behave as expected. Remember, we're using Codescence to find hotspots of the code, but Codescence does not also give us a feedback on the logic, if the logic is executing correctly. So what we had to do is write acceptance tests to check the behavior of existing code base and see what we had to adjust. Then after adjusting the code, we also had to now write unit tests for the code to also test different functionalities in the code and confirm that the code is working as expected. So we had unit tests for the client, the server, and the web API as well. So a layered architecture was followed where the database, the web API, and the client are separate concerns in the code. And then we have the README file as well that describes our project structure, its key features, how to get started, run the server, what command line arguments does the server take, the client commands, and then how the testing and the validation. So that will be it from my section of presentation in the code project. Thank you for your time.